Greetings everybody, Thatna is here, and I am currently a thriving sophomore in industrial engineering. Now, currently I am also taking a quite challenging course that everybody's been talking about lately, which is including me, and it's statics course. Now, I know that some of you might think, oh, my brain is broken, I cannot take this course, why is it so hard? Like, please, release me from this course, I might drop out soon, or whatever. Now, imagine you yourself reading a textbook over and over again, so many hard equations, so many figures, one distributed load and then you're gone, trust me. So by all means, your brain is not broken, but your method is. Now let me introduce you to a website that is called PermaLearn.xyz, a website that helps you visualize, explore, and even solve the problems. I'm going to be solving this exercise from chapter 7, internal forces, 7.7. Okay, the question is, they ask us to determine the internal normal force, the shear force, as well as the moment at points C and D in a simply supported beam. Point D is located just to the left of 5 kilonewtons force. Alright, so let's open our PermaLearn, which is right here. Okay, why is my laptop freezing? Okay, where is my PermaLearn? Now let me just search it up. PermaLearn. Okay. And you got PermaLearn. So on the right side, as you can see, there's light mode or dark mode, but I love my mode light, so let's just put it light. Now this only applies in 2D structural analysis, not in 3D. If you have 3D problems, we are so sorry. Okay, so on the right side, you can customize your own grid size, but I love my 10 meter point 10, times 10 grid size, and the mesh size is, I would pick 0.5. And the unit system is SI. Now click Save Options. Okay, moving on to the support. To the member. Take a look at the picture. We have one member, which is member AB. Now, I'm gonna begin at 2, x equal 2 coordinate, y 2. Okay, and the horizontal distance is 6 meter. Vertical is 0. Now add. Boom, you got a number. Now next is click Save Options, and we're going to the support. We have 2 support, which is pin support and the roller support. Now select a joint. At joint A, we have the pin support. So I click a pin and add. I got pin support. Now at joint B, I also have a support, which is a roller. I click joint B and I click roller. Boom, I got both roller support and pin support. Now click Save Options. Next, there's no hinge in our exercises. There's no joint load. But guess what they have? We have point load. So we're gonna be selecting the member at member 1 with respect to the local coordinate, and the distance from the beginning joint is 0, and the horizontal force, is 3, and the horizontal force is 0. Vertical force is -5 because this is positive upward. There's no couple moments, so just click add. Boom, you got a force, yay! Now click Save Options. And next we're going to linearly distributed load because we have it in our figure. Now click it. And then select a member with respect to the local coordinate system. And the load type is vertical, downward. So the distance from the beginning joint is 0, and the distance from the end joint is 3, if I'm not wrong. Okay. So the beginning load is -3 because it's downward. The end load is 0. Now add. Okay, now click Save Options. Now just take a look at the figure. It's quite similar to the real figure we have on our problem. Okay, now what else are we doing? What else do we do? What's the solution? Now, where's the solution? Don't worry about it. We have a solution right down here. Okay, let me introduce you a little bit back to the linear distributed load or point load or whatever I did wrong. Let's say if I did something wrong, I click edit. Edit what? Edit end load, edit any possible thing I could did wrong, and then I click edit. Okay, but if I don't want to edit, I just want to remove it, I click remove, or even clear all. Clear all means you delete the whole thing. Now we have no temperature change, we have no fabrication error, and we have no support settlement. So it's deep. Let's dive deep into the solution. Now what do you want? The normal force, yeah? Click normal force in the display. Boom, you got the normal force, which is 0. At point C it is 0. Okay, now the shear force. We need to find the shear force at point C and at point D. Okay, the shear force at point C is somewhere around here in the middle, and it's, wait, where is point C? Okay, I'm sorry, this is point C, and for point D, at point C we have the shear force of 2.875 kilonewton, and at point D of 1.725 kilonewton. And you can just click at the, you don't have to click, or maybe you want it to, you can just move your mouse on top of it and you can actually see the answers. As simple as that, right? Now next we need to find the bending moment. Now I click display. As you can see, the bending moment is right here. The bending moment at point C is, right here is 6.5625 kilonewtons. The correct answer. And at point D is 9.75 kilonewtons meter. It's very accurate. Now, this is bending moment reverse. You can display it. Visualization, display this too. Now we have possible answers that we need. Now what else do you want to do? That's it, because it's very simple. It's very good for your visualization. Let's say you want to study for your exams in the middle of the night, you don't know where to start. You can start by solving the problem. If you've understood the concept already, you can start by the problem. And this is the you can play with it. You can play around as much as you want. I mean, the more you play around with the website, the more you get used to it, the more you can ace the exam. Okay, so that's it. Yeah. Oh, if you want to compare the answer I just did back then, let's take a look at the solution right here. So now here is the solution. We got the normal force is 0, at C, at D is 0, and the shear force is 2.875. Yeah, okay, so it's very accurate. As you can see, this is manually solved exercise versus the software one.